So now we need to clean up the product column. So we've cleaned up customers. Now we need to clean up our products. So I'll set this section to clean product. And I'll have a couple different spaces here. And if I want to clean up product, first of all, I think we should probably look at this column. So if I want to call the unique values in lumber product, I'm going to use this syntax, unique lumber product. And then when I run line 33, looks like we have 1, 2, 3, 4, 5, 6, 7 unique values in product. But just me looking at the data, it looks like we have pine, ash, cedar, and then cedar's repeated, pine's repeated, and cedar. So similar problem that we had in the customer column. Looks like we have 3 actual lumber products, but they're all spelled differently, and that's very annoying, but we're gonna have to work on cleaning up those data in order to properly work with them. So let's start off by first rewriting the column called lumber product, and we're gonna, it looks like we have some capitalization issues, so let's just set everything to lowercase. So I'm gonna use the toLower function, and then I'm going to call lumber product. So again, we're calling lumber product, and we're going to set it equal to all lowercase values of lumber product. And I can run that line, and then I can, let's take a look at lumber product. And so we've reduced our values from, I think we had 7 originally, to 5. So we got rid of this uppercase pine, and we got rid of this uppercase cedar. So now it looks like we've fixed the capitalization issues, but we do have a couple different spelling issues, I think, with cedar and with pine, with some missing vowels in there. So how are we going to fix that? Well, we can also use an if-else statement. So I think we're gonna want to use similar syntax to what we did in line 23, where we're gonna call an if-else statement where if lumber product is equal to these spelling errors, then we're going to put the correct spelling. And if it's not equal to those values, we don't want to change anything, and we want to leave it the same. So I think we're going to actually have to use 2 if-else statements within one another. I think that would be probably called a nested if-else statement, which can be a little bit tricky, but I'll try to go through it slowly so you guys can comprehend what I'm working on here. So I'm going to call lumber product. And then we're going to set it equal to an if-else statement. And we're going to start off with if-else lumber product is double equal sign equal to this wrong spelling of cedar. If we find lumber product is equal to the wrong spelling of cedar, we want the correct spelling of cedar, right? And if it's, then I'm going to use another if-else statement. This might get a little bit confusing, but bear with me. If else lumber product is equal to the wrong spelling of pine, we want the correct spelling of pine. Put those in quotations. And if neither of these statements is true, we just want the regular values that are in lumber product. So let's work through this a little slowly. So we want to rewrite over lumber product. And we're going to use an if-else statement. If lumber product is equal to the wrong spelling of cedar, we want the correct spelling of cedar. And if that's not true, we're going to put another if-else statement. If lumber product is equal to the wrong spelling of pine, we want the correct spelling of pine. And if neither of these statements is true, we just want the regular values that were in lumber product. And then we're going to have to close with 2 parentheses because we actually use 2 different functions. We opened up with an if-else statement and then another if-else statement. So we need to put 2 parentheses to close out both of those different functions. And then if I run line 39, let's now take a look at the unique values in lumber product. And indeed, we have 3 unique values, pine, ash, and cedar. We cleaned up these uppercase and lowercase issues, the spelling errors, and now we've cleaned up customers, we've cleaned up products, and now we're looking pretty good. So now we'll probably be moving on to the next column. I think as we just found earlier, the price column had a couple mistakes in that as well. So let's move on to cleaning up the price column. So let's start off by looking at the classification of price. So I'm going to type lumber $price. And price is actually a character, which doesn't really make any sense. There's no reason why at least in this context, there's not a reason why price should be a character vector. We can even look in our window up here, and we can look at price, 600, 500, 6,000. It doesn't really make any sense why this would be a character. And if we're trying to do a statistical analysis on price, let's say we're trying to find the mean of price or the average price, R is not going to be able to compute the mean or the mode or the maximum or minimum values of a character vector, because that wouldn't make any sense. You can only find, do statistical analyses of numbers, you can't of characters. So what we're going to have to do is we're going to have to change it to a numeric variable. So let's call lumber price. Then we're going to set it equal to as.numeric. And then we'll have lumber price. Okay, so I'm going to change lumber price to a numeric variable. And it looks like we have warning NAs introduced by coercion. So looks like there may have been an error. So I'm going to type out lumber price to take a look at how R interpreted lumber price. And it looks like we have 600, 500, then we have an NA, then a 600 and a 3,500. So we have looks like we have two NAs that were introduced. And I think I know the reason because I created this data set. And if we take a look at lumber price, we do have some NAs. And I think originally the issue for this was that there were commas in the price column. So I think there was a 6,000 here and it had a comma. And while other values didn't have commas. So R wasn't able to convert the character vectors with commas into numeric variables because there were inconsistencies relating to commas. So what we're going to have to do is we're going to have to read in lumber sales to get those original values. And then we're going to have to remove the commas manually. So let's create a new data set called lumber2. And we're going to use the read.csv function again. And then we're going to use a quotation and then click tab. And then you can just begin to type the beginning of that data set. And we see that lumber sales comes up. And again, we want to use the skip equals 5 argument so we can remove those first 5 rows. And then when we run lumber2, we can take a look at it. And indeed, we did have a 6,000, so there's an issue with a comma there on row 3. There's an issue with a comma on row 11. And so R wasn't able to convert those character elements to numeric variables because there was those commas in there. So we're going to have to remove those. And what the package that we're going to, or the function that we're going to use comes from the stringr package. So that stringr works with strings. So these are kind of you can think of them as character vectors that have some unique symbols in them. So if I want to take out the commas in the price column, I'm going to call number2, and then I'm going to call price, and then I'm going to set it equal to the string. I'm going to use this stringr remove. So I want to remove a certain symbol or a string within a vector. So I'm going to use stringr remove, and then I'm going to type the vector that I'm trying to work with. So I'm going to call lumber2 price. And then I'm going to use a comma, and then you can use a single quotation and another comma. So what this technically means is R is going to rewrite over lumber2 price, and I want to remove this string, or this pattern, this comma. I want to remove commas from this vector called lumber.2 price. So in this situation, I want to remove a comma, but in other contexts, you may want to remove, let's say, an apostrophe or a unique symbol of some sort. So you can always change the argument within this section. But as of right now, I just want to remove a comma. So if I run line 52, looks like that worked out well. And let's type out lumber.2 to see what it actually looks like. Lumber.2 price. And indeed, we were able to successfully remove those commas. That 6,000 is no longer has a comma. I think there's a 1,000 that had a comma, no longer does. But let's take a look at how R is interpreting lumber.2 price. So it's still thinking of it as a character vector. We were able to remove the comma, but we still haven't converted it yet to a numeric variable. So that will be our next step. I'll start off by calling lumber.2 and then calling price. And I'm going to set it equal to as.numeric. And then I'm going to call lumber.2 price. And then, so now we've successfully changed this vector price to the value that we wanted, but we're working with the data set lumber.2, right? So lumber.2 doesn't have all of the corrections in the customer and product column. It only has a correct price column. So what we'd like to do is all of that data cleaning that we worked with earlier on customer and price on the original data set called lumber. Now we want to combine the correct price column in lumber.2 and merge it onto the original data set called lumber. So my next step is going to call lumber, the original lumber, and then I'm going to call the price column. So this is the one, lumber price is the one with the NAs and the cleaned up customer product columns. And now I'm going to set this lumber price, and I want to set it equal to this cleaned up lumber.2 price. And hopefully that works. And now if I look at the original lumber, we can see that lumber price was able to successfully add in those price elements. And we can look at the classification of lumber price, and it's a numeric variable. So I think we were able to successfully clean up all of the different columns. We had to clean up customers, our products, and our price. And now we can actually start working with data. And we're going to start off by filtering, grouping, and summarizing data using the dplyr package. So I'll create a section in my code called filter, group by, and summarize with dplyr. So these three functions are very instrumental to the dplyr package. Very often when you start a data analysis, you want to use these three functions before you start doing more complicated statistical analyses, and they're often used together. So let's start off by looking at our lumber data. So obviously, as we mentioned earlier, we have a couple different customers, and let's say we want to find the mean price of a purchase from Home Depot. So how would we find the mean Home Depot purchase price? So let's start off by actually subsetting our data or filtering the customer column by Home Depot. So I'm going to create a new data frame called Home Depot, and I'm going to use the filter function because I want to filter the larger data set called lumber, and I want to just only have Home Depot values. So I'm going to filter lumber, and I'm going to filter it by customer, and I want only the customers that are equal to Home Depot. So when I run that line, we can take a look. We see that we've created a new data frame called HD, standing for Home Depot. Take a look at that data frame, and indeed, looks like we had 6 Home Depot values within lumber, and we've subset lumber for only the values that had Home Depot in the customer column. So We were successful at doing that, but now we want to find the mean purchase for Home Depot. So now we can just take the mean value of the price column, and we can do that by creating an object called mean Home Depot purchase, and we'll set it equal to the mean. We've worked with the mean function earlier, mean of the Home Depot price. And then we can take a look at mean Home Depot price. And we can see that Home Depot, the average price for Home Depot is $2,200. So that's one way of filtering data and then subsequently finding the average of a column of interest. But there's also more efficient ways that you can use with the dplyr package that can we call it piping through certain functions or data. So you can kind of combine different functions and use them in very efficient ways. So often let's say we wanted to find the average price of a purchase for each customer. So we can look at our lumber data, and we have 3 different customers, and they're all purchasing different things at different prices. So let's say we wanted to find what is the average price that Lowe's is purchasing, what's the average purchase for Home Depot, and what's the average purchase for Walmart. So how are we going to start this analysis? Well, first of all, we have to group the lumber data by customer. So we can use this group by function that's installed through the dplyr package. So we want to group lumber by customer. And we're going to use this syntax. It's called piping. So I'm going to use, it's a % sign, a greater than symbol, and another % sign. So this is just a really efficient way of writing code with dplyr. So the group by function is going to aggregate your data set by a certain column. So we're taking the lumber data set, we're going to aggregate it or group it by customers, and then we're going to take this new data frame that this creates, and then we're going to do another analysis. So we're going to summarize the data within that are aggregated, and we want to create a new column called mean price customer, because we want to find the mean purchase price for each customer, and we're going to set that equal to the mean value of price. So that might be a little bit complicated, but I'll walk you through it. So again, we're grouping lumber by our customers, and then we're creating a new column called mean price per customer, where we're finding the mean price after we're grouping our data. And if we run lines 69 and 70, we find that we create this mini data frame, data frames working in dplyr called tibbles. It's just another formality of the dplyr package, but we have 2 columns. It's called customers, and then we have the mean price per customer. So like we found earlier, the mean price that Home Depot is purchasing is at $2,200. At Lowe's, it's $1,000, and at Walmart, it's $550. So those are a couple examples of how we can use filters and group bys and summarize 3 important functions in the dplyr package. And now I'm going to move on to our first in-class assignment of class 3. So I will start this section in class assignment. And the assignment that I would like you to work on is, what is the total amount of pounds of lumber for each customer? Each customer has purchased. Okay, so let's just think through this. What is the total amount of pounds of lumber each customer has purchased? So I think what you're going to have to do is you're going to have to use this group by function again, and you're going to have to group by customer, and then I want you to probably not find the mean. I want you to find the total amount of lumber for the column pounds. I want you to aggregate all of the pounds for each customer. So the functions that you'll you will use to answer this question are going to be found and be between lines 62 and 70. You're not going to use mean. I think you're going to use a different function. Hopefully you guys can figure out how to find the total amount of pounds, but you guys can pause the video now, work on that question, and then tune in a couple minutes. Thanks.